two samples from one population. All right. Now the next topic we are going to look at is the independent samples tests. Now in this test, you pick two samples from two different populations. We are in Omu-Aran now. In this sample from Omu-Aran, two samples go to Ilorin from two different populations. Go to Akure, any other Omu-Aran now. In this sample from Omu-Aran, two samples go to Ilorin from two different populations. Go to Akure, any other Omu-Aran now. In this sample from Omu-Aran, two samples go to Ilorin from two different populations. Go to Akure, any other Omu-Aran. In this If you want to use six of them, then you use analysis of them because your groups are now above two. That is why what is very, very important. You see, being of two independent group. So at all times, make sure that you are testing between two groups. In fact, if it's more than two, you cannot even use the test. Because the test will tell you enter the first group and the second group. So if your own group is more than two, there's no way you can add the next the third and the other groups. Some serious assumptions and conditions that must be met. Just like the first two cases that we see. The data requirement for T tests are as follows. dependent variable that is continuous. Now, if you look at all the examples that I gave what? Two variables that are continuous. For example, exam score. And I said the test will be between what? Male and female. It means that you are going to get the scores of male and what? Female. Therefore, you have two scores that are continuous. But the law here says that you should have what? One variable that you are going to call the dependent that is what? Continuous. That is interval or ratio. Then you have independent variable that is categorical. Two or more. This more, two or more, is not right. There has to be two always. So just strike that or more out of it. Cases that have values on both dependent and independent variables. So the issue of dependent and independent variables is very, very important here. Unlike in paired sample where we said that the two of them are what? They are both what? Dependent. If you remember, I told you that the two samples depend on each other. But here, one of them will be what? Dependent, while the other one will be independent. Now, the one that you want to call dependent must always be what? Continuous. I hope we are following. So if you have data and you cannot establish a continuous variable, then you cannot use this t-test. Let me give you an example of how you can use t-test in questionnaire, because some people used to say that they cannot use t-test for questionnaire. It's wrong. You can use t-test if your data is from questionnaire. All you need to do is to get the item means. You know, there's a way you get the mean. I showed you. We saw it on, I think, day 1 or 2. For each item, you get the mean. So if you are using the mean, after all, even the test is all about the mean, right? The test is about the mean. So if you can get the mean, then you can use t-test. But do not use those frequencies. Those frequencies are just counts. So you can't use counts. You can't replace that continuous with counts. But when you get your mean, that mean will now stand as your what? As your continuous variable. Then you can now go to section A, where you have gender, male and female, right? You have marital status, married and single. Okay? Another 2. Then you can use educational qualification, highly educated or not educated. Look for a way to reduce all those long, education, they will say primary, secondary, just reduce it into 2 and then use it here. Okay? Then easily you can use t-test to analyze your questionnaire. But if you are the type that used to get experimental data, then, just get the dependent variable that is continuous and look for a way to factor out 2 categorical. How can we do that? Let's say, for example, you have 2 departments, the score of departments of statistics and others. Am I correct? Department of Statistics and others. I'm right. Very good. Now, no, but you say I'm right before. Hmm? Okay. Oh, you don't have? But I saw one of my colleagues. Look, man, is it not in statistics? Okay, it's in maths. Oh, okay. Okay, with statistics option, I think. Or it's teaching the statistics courses. Okay. All right. So now you have scores from maths department, for example, and you have from biology department. Okay. Now you want to compare their mean performance. How will you now change these 2 continuous variables so that you have one that is continuous and one that is categorical? because that is what the law says. So when we get to the practical aspect, we'll see how to do that conversion. Because if you just go to SPSS, you put discuss for maths, put that of biology, and you are expecting results, it won't work. Okay? All right, because you must follow the guideline, the condition that says one continuous and one categorical. Continuous is dependent, categorical is what? Independent. All right. Now you pick your samples randomly. I've talked about randomly, you pick without favoring any element in the population. You do like a raffle draw kind of selection and all that. Most of our selection in research or in statistics should be random. Okay, we don't encourage this non-probability sampling where you pick because it's convenient for you, or you pick because you have a prior knowledge about the elements. All those ones will lead to bias in your results, and that's why we don't encourage non-probability sampling. And then, of course, we'll be talking about normal distribution. That at all times, make sure the data is normally distributed. Okay? Then, homogeneity of variance. We have been avoiding this. There's a test for this. It's called the Levin test. That's the name of the author, Levin test. We use it to check if you have equal variance between the two groups. Don't forget now that we're talking about what? Two groups now. So you check for the variance of group 1, check for variance of group 2. If they are not equal, then they should be approximately what? Equal. It's a condition here that must be met. Okay? And then the last one, make sure you don't have outlier in your data. Remember the test on paired sample. We had outlier. And I told you that the next thing to do is what? Consider non-parametrics. Okay? So the same condition applies here. You have outlier in your data, or your data is not normally distributed, then you consider the alternative. What is the alternative here? What's the non-parametric alternative? Let's search for it. I know that of paired sample, we said is reclosing rank sign tests, sign rank test. But for independent samples, when you go to page 51, you will discover that the alternative, the non-parametric alternative there is the Mann-Whitney U test. Okay, Mann-Whitney U test or the Kolmogorov-Smirnov Z test. So any of these two tests can serve as the alternative to the independent sample state test. Have you seen it on page 51? The second slide on page 51. So where you have failed to meet up with the conditions, you use any of these two tests, Mann-Whitney and Kolmogorov-Smirnov test. So supposing we're dealing with manual computation, now is the time for me to write out the formula for you. Okay? Write out the formula and then start explaining all those parameters in the formula, how you do your addition, how you divide, subtract, and all those. But it is purely an SPSS practical class, okay? So what I need to show you is how to use SPSS to do this computation, okay? But don't forget that I said it is necessary or important you quote the formula. I have it somewhere. I will display the formula for us later on how to carry out this computation. I know you get your t-tests those days, okay? That's how we used to do. You get your t-test, and then you compare your t-test result with the critical value result. Some people call it the table value or the tabulated value. You know, you go to your 4-figure table, you see those values there, you check. That is the old method. If there's any researcher that is still using that method now, then we have to. But there are some schools that up to now, that's what they do. Some professors are there that do not know about statistical software. When you use software, they will be asking you, where is the computation? Where is your table? Where you compute? They will ask, where is the formula? How did you? Because during their time, that's what they know. So they are expecting you to do the same. We still have some of them up to now, though not in this school anyway. But when you go far north, we have been to some schools where they will argue that how can you now say you will not do all those calculations, that is this one correct? They're arguing in the class with me. Say no. I said, sir, that's why we are here. We are here to tell you that this method is old and you will even get wrong results. If you do all those methods and you have a result and you think you are right, when you check very well, you discover. Even those of us that used to teach our students, while we are even doing the calculation in the class, is the student that will be telling you that, sir, you didn't add this one very well, or you didn't divide very well. For you to know that it's difficult for you to use all those, and get, though we still get it, but always you discover that there's error somewhere. But with software, no, you can be 99% sure of your results. All right, so that's a brief background information about t-tests. We use p-value usually to take our decision. Then we check for the 11 tests. And the law of that 11 test is that if your p-value is greater than your level of significance, it means you have met that condition. It means that the variance in the two samples are equal or approximately equal. So when we take the tests, you'll see how to get the 11 tests. All right. Let's quickly go to our data. We have data for independent samples from the ones I sent to us. Let's check. Oh, I think I've opened that one before. Is it this one? Is it this first one? No, we have used that one. We have used 1 and 2. Let me open this one and see. Okay. All right. We have tests between male and female, pre-tests. Okay. Yes, we can use this one. We also have male and female for post-tests. All right, we can use this. But we have to work on the data because now the variable will be strange because you have words or alphabet in your cell now. And the law says you don't insert anything apart from what numbers. Now that we have word here, you cannot run any analysis here. So let's start by removing these 2 lines. Don't forget that the first one here is female, while the second one is male, okay? So let's clear this and that. So where you have gender, that's the scores for female. Where you have cooperative learning strategy, that's the result for male. So let's change that. Female and male. All right, and then change the string to numeric. All right. So we are trying to compare between male and female now. Performance in that is it pre-test? Yes, this should be resolved for pre-test. You know, we are still on that same data that we used before, cooperative and conventional. I know for cooperative, we have pre-test and post-test. For conventional, we have pre and post. We also have results for male and female. Even location, we have results for location and so on. So this is what I'm talking about. Now, when you look at these two results, they are results, pre-test results for a particular teaching, in fact, for normal teaching, because here they've not applied the teaching method. That's why it's called pre-test result. So what I'm trying to say now is you have two what? Two continuous variables, and the law says you should have one continuous and one categorical variable. Now I want you to look up to see how you are going to rearrange this data so that you have one continuous and one categorical. We have not stated the hypothesis yet. Let's rearrange first. Are we ready? Are we ready? Because I want to get your attention on this. Are we ready? Are we ready? Shotiya Ogu. I wanted to speak Igbo, but we want to rearrange this data. The analysis, we want to test if there's significant difference in the mean performance based on gender, or the mean performance between male and female students. So who can restate this, my hypothesis, very well, in a meaningful order or way? Our test between male and female for a test for male and female. Who can help us with the hypothesis before we continue? Between male, okay, between the mean score, mean pretest score, there is no significant difference between the mean pretest score. There is no significant difference in the mean pretest score between male and female students. There is no significant difference in the mean pre-test score. In the mean pre-test score between male and female students. All right, so you can state the alternative, right? All right. No, it's the same thing. Okay, the zeros. You have 3 zeros. Me, I have 1 0. You can reduce it now. Go to variable view. V4. It's for V4. All right. Now we are done with the hypothesis. Let us rearrange this data. I want us to insert a column here. before female. Please, let's insert a column before female. I'll just go down. Waiting for the next move. How many females do we have? Please count. How many data points do we have for female? 100. Okay. Therefore, we are going to enter 100. We are going to enter 100. Let's see first to finish. Okay, copy one and paste. All right. How many? So after that, typing 2 for 91. You are through? So 100 times, then 91 times. And when you add 100 plus 91, you have the total of 191. So the one, hey, take it easy, take it easy. What is happening? Calm down. Okay, me. No, me, I'm telling you to. But me, I should. All right, now one person should just tell me why the whole. On behalf of yourself or everybody now, like.
adding 111 to 100.
Do you know why we have 1 100?
No.
Okay. Now let's start with this. Let's, you see, female, I asked that how many, what's the sample size for female?
We say 100.
And we all say 100.
Yes.
And that is why we have 100 of the 111.
Okay.
Do you understand? Then I also asked that how many males do we have? And you said 91. Therefore, we have 2 and 2s. Start from what? 101.
Okay.
Let me take you to 100. Let me take you down to where. Just follow this 111. You see that it stopped at 100. All right. Can you see it? And then the 2 now started from where? 111.
That's very good.
So we have 2, 2, 2. We found to make sure it was 91. Because we have 91 males. Okay now. Try it, let's see for now. All right. So 111 up to 100. Then from 101, you now start your 222 for male, which is 91. Sample size for male is 91. That for the 222 will be 91. Sample size for female is 100. And that is why our 111 was 100. Is it clear now? Can I continue? Oh, there's one loop. Let's wait for the loop. Wait the loop. All right. Can we continue now? All right. So don't forget that the 111 is for male, female. Sorry. And when you look at what we have here, the data for female is already attached, but that of male is not. So you have to cut that data for male. Highlight and cut, or you use control cut and paste it beside where your 222 started. That's from 101. Cut the data for me. Copy and cut and paste it beside where your 222 started. Cut that data for me. And cut. How we have done that? All right. Now you discover that we have met that condition. Okay? Condition says we should have one independent variable that is what? Continuous. So this is dependent variable that is continuous. And then another variable that is what? No, the independent variable that is what? Has to go with that. Either nominal or ordinal. So now let's rename this 111 and 222. They are now the gender. Are we together? Yes. Is the gender. While where this female is now is our pre-test score. All right, so let's go at the name. The 111 is our gender. So just type gender where you have that gender. While female is a pre-test score. Pre-test score. Then you go to values under gender. You know, you have to give SPSS that command. What is 1? What is 2? Who can answer that? What is 1? 1 is female. All right, so you give SPSS that command that the value of 1 means female. And then you add. Value of 2 means male. Okay, thank you. Take. Let me just give you take. 2 means male. Then we add first before we okay. Are we together? Now, after that values, don't forget to name your measure. Can you imagine? The measure is telling us, it's telling me scale. It's not scale. It's what? It's nominal. It's not nominal. Change it to nominal. And then the pretest score now becomes scale. What about the role? Role for gender is independent, right? While the role for the pretest score is target. That's dependent. All right. So we are through with that information. Then we can now go back to sir? Pretest score is scale. And the role there is dependent from the background information I gave you. That continuous data are what? The dependent variable. While the categorical are the independent. So we have met 2 of those conditions, right? We have met the first and the second condition. Let's go through that condition again. Condition for using these t-tests. Condition number 1 says dependent variable that are continuous. So this is the dependent variable now. The pre-test score is the dependent variable and it is what? It is continuous, right? The second one says independent variable that is categorical. Okay? And we have it here. Gender. We have 2 categories there, male or female. So we have met that condition. All right. Now let us meet the other condition of normality and outlier. Let's do that in the next 2-3 minutes. Let's test for normality. Which one are we going to test? Is it gender or pretest score? Pretest score. So let's test pretest score for normality and outlier. All right. Do we have our results? What is the result there? Oh, it's not normally distributed. It's not normally distributed. Let me see your passive. Wait now. It's not the outlier, the normality test first. Wait. See. It's not normally distributed. So what's your conclusion? It's not. Of course. So it's not normally distributed. Therefore, we cannot continue with t-tests. Okay? Are we together? Though, supposing we have time now, we'll transform the data, but there's no time. You know, there are two things actually for us to do: transform, take normality test, or just go straight to the non-parametric equivalent. But as usual, let us see how to take our analysis. Let's assume that we met that condition. Is that okay? All right. Now, to take this test, you go to analyze, compare means, and then you go down to independent samples t-test. Independent samples t-test. Then you click on it. Let me wait for those of us writing. Analyze, compare mean, independent samples t-test. We have this dialog box. Now, we have test variable and grouping variable. Test variable and grouping variable, just like saying dependent and what? Independent. So, which one? Let's talk about this grouping variable. Is grouping variable the independent or dependent? Independent. Why did you say it's independent? Okay. The test variable is the scores. All right. And moreover, that gender is grouped into what? Male or female. Therefore, gender goes to where? It goes to the grouping variable. And then the test variable, which is now the pre-test, goes to what? To the test variable. Yes, we have a question mark, and we cannot even perform this analysis yet. Because see, okay is not activated. So it means you have to click on that question mark. Click on it. When you click, you discover that the defined group is active after clicking on gender. Therefore, you now click on that defined group. Group 1 is, what is group 1? Remember that in SPSS, you don't use words, you don't use alphabets. So group 1 is 1. Group 2 is 2. All right. Continue and okay. And the good thing with SPSS and other software is that immediately, it's not even up to a second, you'll see your results. All right. Now let's report as usual our results. We have the descriptive table and we have the main test table. The result shows that we have 100 female and 91 male. Independent. The sample size for female is 100, while that of male is 91. The mean score, the mean pre-test score for female equals 39.3. While the mean pretest score for female, for male is 37.3. The mean difference between the male and female score equals 2.087. The mean difference between the scores of the male and female is 2.087. T calculated, the T calculated equals 1.432. Degree of freedom. Degree of freedom equals N1 plus N2 minus 2. N1 plus N2 minus 2 equals 100 plus 91 minus 2. Equals 189. And lastly, p-value equals 0.154. I told you about this Levin test. There is a test for what? Equality of variance. Or some people call it homogeneity of variance. Look at the results there. The results there is F. You know, okay, no. We have p-value. So p-value, let's use the p-value. P-value there is 0.943. Levin test result for homogeneity of variance. Or if you don't understand that homogeneity, it means equality. Levin test for equality of variance. P-value for the 11 test of equality of variance equals 0.943. We are using P-value there. Yes, for 11 tests. 11 tests is a pre-test. Don't forget. 11 tests is a pre-test, not the main test. You know, it's one of the conditions that we must meet. So it's just a pre-test. So as far as this result is concerned, we have met this condition here. Okay? Because condition says that if your p-value is greater than 0.05, it means you have equal variance. And this p-value here is more. Okay? It's more than 0.05. Therefore, we have met that condition. Even though we didn't meet the two most important conditions, at least we met one. No, we met three. We were able to meet three. You know, the grouping we did, okay, and then this test. So we were able to achieve 3 out of how many? Yes, p-value. Yes. To check for equality of variance. It's not a real test. Okay? It's a preliminary test. It's one of the assumptions that must be met. Okay? So that's not our test. It's a pre-test. Let me take you back to our conditions again. Let's go back to page. Where is the page again? Page 64. The second slide on that page 64. We have 1, 2, 3, 4, 5, 6, 7. The seventh commandment. Now, we must meet that condition that says homogeneity of variance, that is, variance approximately equal across groups. So how can we meet that condition? Is by reading the p-value under the 11 test. Do you understand now? So it is not our tests at all. It's just a what? A condition for using t-tests. And we have met that condition. All right. No, unfortunately, but some other packages anyway, you can do that test separately. But for SPSS, it comes with the result this way. All right. Now I think we can start with the interpretation, right? From the result presented above, it can be concluded that the female performs slightly better than the male students. The female students perform slightly better than the male students, with the mean difference 2.087. So that the female will not start jubilating. The difference is just what? Just 2. In the next test now, you can catch up. The difference is just 2 now, 2.0. All right. P-value. P-value equals to 0.154. P-value equals to 0.154. I forgot to explain something. You see, this test, this 11 test is very, very important. Okay? And that's why you see we have 2 results here. If you notice, we have equal variance assumed. If you meet that condition from here, you know we have met the condition here. So you take your readings from what? Equal variance assumed. But when you fail it, you now say equal variance. So all your readings will now be from the second. So we are picking the readings for equal variance because we have met that condition. Is that okay? But when you fail to meet that condition, you just take your reading and you see they are almost the same. They are almost, it's just the degree of freedom now that is different, right? All other readings, they are the same. Yes. So just take note of that. All right, so I said p-value equals what? 0.154. Equals, sorry, greater than, is greater than the level of significance. Is greater than the level of significance equals 0.05. Therefore, the null hypothesis is accepted. Therefore, the null hypothesis is accepted. Those of us in statistics will say we do not have enough reason or evidence to reject the null hypothesis. But for you, the non-statistician, just say the null hypothesis is accepted. Then we conclude that there is no significant difference. There is no significant difference in the mean. There is no significant difference in the mean pre-test score between the male and female students. Female students will not jubilate. You can see now that that difference is not even not significant. It's not something you take seriously. It's negligible. That difference is an neglect. All right. I hope this is okay. And I hope you can replicate this step because we are going to take 2 classwork now. When are we going for break? In fact, whether we are going for break or, okay, we still have time. What's the time? We still have time. All right. Questions before we take our classwork on this? So that I don't just assume that you understand me. Let's go back to our data to pick another data to use for classwork. Let's see how we can arrange. The first one I want us to look at, that first data that we use for paired samples. I think it's this one. All right. This is what I want us to do. From that paired samples data, you discover that we have pre and post for cooperative, right? And we also have pre and post for conventional. This one, look up, these ones, they are the cooperative. The first one is the pre, the other one is the post. Then this one is the conventional. Now what I want us to do is to find out if we have difference in mean between the conventional and the cooperative. I know it's 2 analyses we are going to take. We are going to take conventional for pre-test, cooperative Please write it down so that you can get the work, because if I'm just saying, now there are two tests actually. We want to test between cooperative. So write number one, cooperative versus conventional for pre-test. Then the second one is still cooperative versus conventional for what? For post-test. Because this research actually is a comparative analysis between these two teaching methods. Do you understand? So now is the time we want to take the real reason for this research, to test between what? The two methods. So the first one will be based on pre-test. The second one will be based on what? Post-test. All right. Good luck to us. If there's any question, you ask me. We have 20 minutes to do this because we'll go for break by 1. The first advice I will give here, or hint, the first hint I will give here is just lift this data out from here. Open a new sheet, okay? Now you want to test conventional and cooperative. Lift the data for pre-cooperative, pre-conventional, remove it. Keep it somewhere. Then open another sheet, remove post-test for cooperative and what? Post-test for conventional. Remove it from here. Then you can now start there's no need for you to test for normality. Don't let us waste our time with that. We already know that they are normally distributed, right? So don't worry, you can do it. Don't worry, you can do it. And for the first time, I'm going to take somebody up that's my computer to demonstrate to us how he or she did this analysis. I know it's going to be a she anyway, but let's wait till then. Don't forget, this test is not about pre and post anymore. I hope you understand that. It's between cooperative and what? And conventional. So the issue of pre and post doesn't arise. You test between conventional and cooperative. The first one will be for pre, the second one for post. I'm going to leave this because this one will serve as a guide. Hmm? Is it the cooperative or the conventional? For those of us that are finished. For the two, check for pre, which one is better? But the most important test is post. That post test for conventional and cooperative. That is where we take our final conclusion or decision on this research. Yes, yes, yes. Which one is better? Which one is the best? I said that post, the result for post is the one that will give us the final decision on this research. Cooperative is better. The mean is higher than that of conventional. Wow. So we have a new discovery now. But don't forget, somebody's work. All right, so we are waiting for the prof there to. We are waiting for prof to come and show us how we, rearrange this data. It's very, very important. Yes. Prof, are you ready? But we had that agreement before. What happened? So who can help Prof to show us how to do these arrangements? Don't let the ladies take over this. Okay, since there's nobody, I guess I have to do it myself then. Come out now. So I have a new, please don't press it. Just leave it away.
Please, I'm not teaching anybody here. I have my teachers here. So,
All right.
Our teacher has already assisted us by copying I think this is the pre-test. Please, can you confirm? This is the pre-test. Okay. The values for the cooperative method is above. So I'll just copy, and then that for, let me just copy both. And then that's for the, okay. And that's for the conventional is beneath. So we'll copy. And paste it on a fresh sheet. Okay, so have some more. Okay, so we put this, like you taught us before, cooperative method. So we have one all the way. Convention. So once this is done, we can adjust the variable view. So here we have the type of method. And then here we have pre for short. Say teaching method. Teaching methods. Okay, and then the scores. Okay, thank you, sir. Scores. It's really becoming difficult. I hope I'm not. Okay, we need to put the values. So here we have one represents yeah, male and female, but this is cooperative. And the second one, number 2, represents conventional. We'll add and then we say okay. Here we are fine. I think the next one should be the measure. So for the methods, it will be nominal. We have just 2 categories that, and then for the scores, we'll have skill. So the role too, the first one should be input, while the scale should be our target. So I hope I'm in order. So with that, I think we are set to analyze. So we go to analyze, compare means, independent. Okay, well, so should we add the post test to this, or we can just work on the pre? Okay, let's add the post before we. Okay, let's add the post. Yes, I think this is the post test here. So let's have this. Okay, this is the post. Thank you. So, post for cooperative should come up, and then pre for post for conventional will come down. So let's copy this first. Paste, and then we'll pick that for we'll pick the post for I'll still copy it when I get to the other end to make it easy for me. Copy and then paste. So we have the 2. So this time around, the variable, so that we can have our 1, 1 by the side. Okay. Let's move this. So we'll cut and underneath this one, paste. So we're using the same method for both the pre. So let me edit this now as posts. posts. So we can still label this as well, posts scores. And then the value, it's the same thing. This is okay. I think we're done with that. Yes. The measure, I think is on, okay, we're on scale already, so we are fine. And target too, so I think it's okay. So we can go ahead with the analysis. Okay, so analyze, compare means, am I in order? Then independent sample t-tests. Okay, so now we select which should be in the test variable, the dependent, right? And in this case, it is pre. So I have a question. We can take the two, exactly, that was my question. So we have these two. Thanks for answering. Then teaching method should be the grouping. Then we need to define again. So we are defining group 1 and then group 2 as 2, which is the okay, and our results.
So I need a male participant to do two things for us. Reports and give a detailed and comprehensive interpretation. And this one is easier. Just sit where you are. Okay? Sit where you are and give this interpretation. Because this job is not complete if we don't have this interpretation. All right, we are waiting. If no mail is ready, then I will pick one. We are still waiting. They want to disgrace me the meeting, of the minutes of the meeting. They want to disgrace me. No camera. Please. I need a mail. Prof. Please, Prof. It's stretching. Prof, help us, please. Prof, help us.
All right. What exactly do you want me to do, sir?
Okay, let me make it easier. Just report. We'll look for another main participant.
Well, I will over summarize. Sorry, my glasses cannot see this very well. Okay, let me use mine. It's a bit far from the. Sorry about this. Okay. Well, from the pre-test results, the cooperative was observed to, the mean scores for pre-test results of the cooperative method was observed to be higher than the one of the conventional, and was observed to be actually it was actually significantly higher than what was found in the conventional. Then the same thing for the post-test, the mean score of the cooperative method was observed to be higher than the mean score of the conventional method, and that difference was also observed to be significantly higher. What is the other one? The mean, with a mean difference of 12.56. I think I'm done, sir. Thank you.
All right, let's appreciate our prof. Thank you, prof. But I wanted us to report first before you actually interpreted. And usually, what we do when we have a result like this is to report first. The first paragraph in our interpretation will be to report all your results. Report your your mean first. The mean. So I will just go straight to the post scores, because that is where the main decision is. After you have used cooperative method and after you have used conventional method, that's the post test. Now, the mean scores for students taught using cooperative method was what? 76.84. While the mean performance of students taught using conventional is 64.28. And the mean difference between these two methods is 5.27. Have you seen it? 5.27. Then the F, or the p-value for the Leven test of equality of variance, is 0.001. For the posts is, 0.571. Thank you for that. Then the T calculated is 11.96. Degree of freedom equals N1 plus N2 minus 2 equals 191 plus 188 minus 2 equals what? 377. P-value equals 0.000. Okay, so this my 5.2 is not correct because we are taking our reading from post. So the difference is 12.561. The difference between the conventional and cooperative is 12.581. But if you notice, it's not all the results here that I'm talking about. Yes, you have to report first. We don't jump to interpretation. You report what is on the table first, on the results table first, and then okay. All these figures. Okay, that is just that you should go straight to the interpretation. Yes. Well, if you don't want to do that, you can just come under the table and just do that report there. If you don't want it to be in your interpretation, just write it down here. P is this, T is this. Even the decision, you can say P greater than this or less than this. you do a summary of, the results and interpretation first. But not reporting at all is not advisable. Not reporting the results is not advisable. All right. Now, let's go to the interpretation. Since P equals to 0.00 is less than, level of significance equals to 0.05, the null hypothesis is rejected. Since P equals to 0.00, since P value equals to 0.00 is less than level of significance equals 0.05. The null hypothesis is rejected and the alternative hypothesis is accepted. This implies that so what did we state as our null hypothesis? What was our null on alternative? We are accepting the alternative now. So you now write that statement. There is a significant difference between students' thoughts using cooperative and conventional method. All right. So with this, I think I'm satisfied now that you can handle t-tests, whether the one sample t-tests, the paired samples t-tests, and of course, the independent sample t-tests. Any question on this? Is there any area on t-tests you will need further explanation? Let's talk about it now before we go to the next topic. Oh, break. Is it time for break? It's not time yet now, it's 2. Break is 2. All right. Okay, that one is not a question. So let me not say any other question. All right, so since there's no any, let's take the next topic, which is the analysis of variance. The one-way analysis of variance. ANOVA compares the means of 3 or more independent groups in order to determine whether there is a statistical evidence that the associated mean, population mean, what page is it? 65. Let's go to 65. Show me what you used to. Okay. The one-way ANOVA, analysis of variance, compares the mean of 2 or more independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. Don't forget, it's 3 or more. If it's 2, you use t-test. So correct that sentence or that word. 3 or more. The test is also known as one-factor analysis of variance. One-way analysis of variance. Now, in that our example where you have scores, whether the pre or the post. You know, we had gender. In the first case we looked at, there was gender. And there's another test there for location. So for these two cases, we cannot use analysis of variance because the factor there has what? 2 groups. But let's say we have other factor like departments and you have 3 or more. Then you consider using what? Analysis of variance. So what we are saying here is that you have one factor that has what? 3 or more groups. If your factors are 2, then you use two-way analysis of variance. Let me give you an example of a two-way analysis of variance. You have exam score, and then you have departments, 3 departments. Hours, different categories of hours that the students spend, you know, preparing for the exam. So that hours is what? Is one factor. Department is another factor. Factor has 3 groups. Don't forget, 3 departments. Factor has what? 3 or more group. Because you now have the range of time. Maybe 1 to 9 hours, okay? 19 hours, 19 to 24, no, 0 to 9 hours, 10 to 19 to 9, 30 to 39, and so on. So there you have what? 4 groups in hours. And you want to carry out this comparison. Now, comparison is about 2 here anyway. You want to find out if there is what? Difference in the mean performance based on the departments. You also want to find out if there is difference in the mean based on the hours they spend. Then the third one is want to find out if there is an interaction between the 2 factors as far as what? Performance or exam score is concerned. So that is when we use two-way ANOVA, because I may not have the time to explain the two-way ANOVA before we just take the practicals. So the first one way, you have one factor that will have 3 or more groups, okay? The other one, you have 2 factors that will also have 3 or more groups in each of the 2 factors. But your dependent variable is what? Is 1, which is what? A continuous data. So don't forget, you must have 1 continuous and 1 categorical, just like t-test. I hope I'm communicating. 1 continuous that you are going to call dependent. 1 categorical that you call independent. The difference here now is that categorical is now 3 or more groups, not 2, like the case of T. That's just the difference here. Okay? All right. Now let's look at the conditions that must be met before we can use one-way analysis of variance. Dependent variable must be continuous. I just said that. The independent variable must be categorical, 3 or more groups. cases that have values on both the dependent and independent variable. So let's say your data comes in departments A, B, C, and you also have it in, based on the hours, so that you have just one continuous, then you have one independent or two independent. That is a one way or two ways. Then we test as well that the continuous variable must be tested for normality. And just like we did for t-test, you also carry out the homogeneity tests, the 11 tests. And don't forget the condition. P-value must be greater than your level of significance for you to meet that condition. And the last one, you test for outliers. So she mentioned Duncan yesterday while that we don't have just one when it comes to what we call post hoc tests. In analysis of variance, we do take a further test called post hoc test. Some people call it the multiple comparison test. Okay? Well, you can see all the 14 tests that you can use. And the condition of guiding these 14 post hoc tests is that you must have met that condition of equality of variance. Okay? When you meet the condition, then you can use any of these 14, LSD down to Dunet. Have you seen it? Though the most commonly used one, in fact, there was a conference we went where somebody did one research, presented a paper in that statistical conference where he carried out comparative analysis between these 14 post hoc tests. And from his own findings, he said LSD is the best and can be used by all data. That was his findings. Then he said the next, if I can remember, is he talked about Tukey. And then for the first time I had Gabriel. I didn't know that because Gabriel wasn't that common. Then he said Gabriel was the third in his ranking of the best multiple comparison tests that we have. Though the ones we normally use, we use LSD, Tukey, Duncan, and Shifi. So, but when you look down there, you see that we have one Gabriel. I don't know how he arrived at that, his own conclusion, but that was his findings. But when you fail the condition of equality of variance, look at the four. The Tamfene, Dunet, Game, Howell, and Dunet C. Okay, the first one is Dunet T3, and then the other one is Dunet C. So those are the methods that you use when the condition for equality of variance are not met. Okay, so we don't just use them. Okay, you must also consider whether you have met that condition. Is that okay? Because I know most of us, we don't consider that. We just pick any one of our choice. Well, some of these comparative analysis, you see them, they will give you, if you have 4 groups, for example, and you have rejected your null hypothesis. That is the condition anyway for using this test. You must have rejected your null hypothesis. So if you are using analysis of variance, it is not automatic that you must use post hoc test. That is a mistake that some of we researchers make. Okay? It's not automatic. you have to take the test first, the ANOVA test. Check your p-value. If your p-value is less than your level of significance, it means you are rejecting your null hypothesis and concluding that there is a significant difference of the what? The 3, the 4, or 5 groups you are comparing. Now, the duty of post hoc test is to tell you or to tell us the exact difference in mean. Let's say 1 against 2 now. You know you have 4 groups. What and 2? Post hoc test will give you that difference. And we also tell you whether that difference is significant or not. Oh, you are writing down. Which one? Where? Okay. I said that using post hoc test is not automatic. That for every time you perform ANOVA test, 1 way or 2 way, it's not always that you now go ahead to use this post hoc multiple comparison test. That the condition guiding it is that you must have rejected your null hypothesis. It is only after you have rejected your null hypothesis that you can now do a further test. You now proceed to the post hoc tests. The 14 of them, if you have met the condition of equality of variance, or the 4 down there, if you have failed the condition, if you have failed in meeting the conditions. I'm still too fast. Hey, that's serious. All right. So where do I start or continue from? Check what you wrote so that I will know where to start from. Where did you stop? Where did you stop? Yes. Null hypothesis. Is that where you stopped? Okay. All right. He stopped at, you take a further test only after you have rejected your null hypothesis. All right. Okay. When you reject your null hypothesis, what does it mean? It means you have significant difference in the mean of the what? Groups. You are trying to tell us that the mean of group 1 is different from the mean of group 2 and 3 and 4 and so on. That is your conclusion by rejecting the null hypothesis. All right. Now, LSD, Duncan, Shiffy, Tukey will tell you the exact difference. If the difference between group 1 and 2 is 20, you will see it. It's just like you have 4 departments now. Department 1 and 2. You can even use 1 as the control here. Okay? Now, control that is 1. What is the difference between control and the second department? You will see it. It will write it out. And it will also tell you whether that difference is what? Significant. Then you can take control again, which is 1, against what? 3. What is the difference in score between 1 and 3? So it will write it out for you. And we also tell you whether it's significant or not. Then it will go again, 1 against 4. So until it will count all the groups that you have, all the departments, all the groups you are testing. I hope it's okay now. So it's it's a very good test. But where you are concluding that there is no significant difference, then what are you checking using post hoc? There's nothing. Because already the conclusion is no what? Difference. So you don't need to take any further. I hope you are getting it now. All right. So that is the, and let us know when to use this test, because I know that we are great researchers. I went to some of our Scopus page, I saw a lot of publication. Very good. Me too, I'm trying to catch up. I'm just on 25 now. I know those of us in Federal, they are looking at me as, very, very good when it comes to publication with just 25. I saw some of you, 70, some 50, some 40. It's awesome. It's not. I used to think it's awesome before, but when I started seeing you people in Covenant and here, I know I've not done anything. Of that 25, how will you check? Let me go and check it. I don't know how to check. How do you check the percentile? On the page, okay, to write it there. Okay, Scopo, what of in Google Scholar? It will not write the, you see, of the publications you have. All right. So, why I'm saying this is, we should know when to use some of these tests. Let's talk about it. When do we use this test? What kind of data will you have that will now make you start thinking of using analysis of variance? All right, the floor is open for us. Let's look at the time. Yes. When do we use analysis of variance? Do we just jump into that test? Just like my people in University of Abuja that will say, just do analysis of variance test for me because I just like the name. The sound fits. Sound very statistical in nature. When you have more than 3 groups that you want to test for difference in their mean, you see, before you start talking about dependent or independent, the first thing that will come to your mind is that you have 3, 4, 5 groups. Okay? So you are the one that will now convert that 3 or 4, 5 group to 1 dependent and 1 independent. But the way your data will come, it will come in form of what? 3. Location A, you have a continuous data. Location B, you have continuous data that you collected from that location, and so on. Then when you want to carry out the analysis, that is where you now rearrange the way we did for t-test. Then you will now have 1 categorical, okay, and 1 continuous. Of course, for ANOVA too. 1, 1. 1 for categorical, 1 for continuous. But your data will not come that way. It will come in form of groups. 4 group, 5, and so on. So you have to come back and do what? Rearrange your data. Do you understand now? When we come back from break, we'll see how to do that rearrangement. Because some of you will just be thinking, just like she said, we are talking of 3, 4, 5 groups. How can I convert 5 groups to 1 row, 2 columns? Because for you to take that analysis, the condition says 1 column that is dependent, another column that is what? Independent. That dependent will now be your what? Your continuous data. That dependent will be your what? Continuous. The independent will now be the group. All right. Any other question? We'll see that when we want to do the practicals. We are just talking about, all what we need to know about analysis of variance. So we said that our data must be continuous. We have to regroup and all that. Any question before our lunch break? Because I want us to come back fresh, strong, and then we take that practical. We'll have 2 practicals to take and 1 classwork under this ANOVA. All right, if there is no question, let's go for at all. The only test where you need equal sample size is the paired. And I told you why. That you are pairing. For any element to pick in group 1, it must have a partner in group 2. So that is the only reason. But every other you can have on equal sample size. Okay.
Now let's say we have week for infection, maybe the constant, the weekly.
Okay.
We have the suspected cases, family, death, and all those. So how do we determine
you have to rearrange. Okay. If you are talking of 3 or 4 types of diseases, you have to rearrange them in a straight line. And how are you measuring them? Are you measuring them in terms of an experimental data that is numeric? So you have to rearrange them and make them 1 column. Okay, 1 disease against what? Against maybe 3 or more weeks. Fine. If it's 2 weeks, you use the t-test. But if it's 3 weeks, you now group 1, 1, 1, group 1, 2, 2, 2, group 2, week 2, and so on. Yes, that's what we are going to do. We're going to have 52. But I don't think SPSS can handle, there's a limit it can go. It can't go up to that 52. So we have to break. Because 52 will be too much. I think the maximum could be maybe less than 20. Okay? Maybe into months. Or even into quarters. The quarters we have in a year. Because that 52 will not go in ANOVA. It's too much. Impacts, influence, effects. You can't use ANOVA for that. You use regression. Regression, either the simple or the multiple. Probe it. If you are talking of 0, yes or no, good or bad. In fact, tomorrow we'll see all those. So anything that has to do with effects, consider regression for that. All right. Any other question before? Nobody wants us to ask questions again because we want to go for break, have we? I know. After